In this video, I would like to explain the concept of area between curves. You really have one formula, but that formula can take two different looks for finding the area between curves. Generically, we'll start off with this. It's the area is equal to the integral from a to b of f of x minus g of x dx. Specifically, you'd be looking at f of x being your top function, so whatever's on the top of your picture, minus g of x, which would be the bottom function. And this would set it up as a slicing idea. So you may have a picture that looks like this. XY plane. You have a function that's running up to the top. And then maybe you have a function that's beneath that. I'm just going to make it a linear function. And notice it doesn't matter where it's located in the XY plane. It's really you just talking about the top function versus the bottom function. And then we're going to slice it. The dx part is the slicing. So it's very much like our rectangles we were doing with Riemann sums. We're just going to slice this so that each of our widths is a dx. And this formula will find the area between those curves. And if you think about it, it actually makes a lot of sense, because if we're saying that this is A and this over here is B, you can see the rectangles. This is simply a height, and then we have a width that is dx, so it's a height times a width. Height times width, when you integrate it, you're just adding all those up. It's an infinite sum of all those rectangles, which gives you that exact area between those two curves. Now, I said at the beginning of this video, there's one concept, but it can be portrayed two different ways. You could slice vertically, that's the dx concept. You could also slice horizontally, and very same formula, just different notation. Your area is equal to y equals a to y equals b of, now I just called these different functions here, h of y minus k of y dy. And basically what that is telling you to do is you want to go your rightmost function minus your leftmost function with respect to y. So that means that your slicing will be horizontal. And I'll draw a picture of this as well. So maybe you have a function that looks something like this. Let's do a parabola. It's been kicked over on its side. Now, a formula for something like this might be like x is equal to y squared minus 3. Maybe it's something like that. And then you have, once again, you could have a line here. Maybe it's a line that shoots up like this. As you look at this picture, you always have a rightmost and a leftmost. So in this case, you go your line minus your parabola. And you could slice this horizontally. If you can find the distance between your parabola and your line, and you have these infinitesimally small widths, or in this case you might call that a height, you could simply stack up all of those rectangles. As you stack up those infinitesimally small rectangles, you would find the area between the curves. So in this situation, you're going to do your right minus left. And this notation here, if you've forgotten, when it says h of y, it just means that you want everything in terms of y, so you solve for your x. And you would do the same for your line. You see, if I go back up here, this would be solve for x. So this is all in terms of x, and that's my top function. So I have this all in terms of x minus the bottom function, that's all in terms of x, so I solve for the y's. So I solve for y's, so everything's in terms of x. That would be a top minus bottom. Second situation, you solve for x, so everything's in terms of y, this would be everything in terms of y minus something in terms of y, and that would be a horizontal slicing. Now, when you do go right minus left, the integral from a to b, a has to be down here. It's your bottom value. This would be your a, and up here would be your b. That's the concept for the area between curves. You have two setups. One for vertical slicing, which is everything's in terms of x. One for horizontal slicing, where everything is in terms of y. And that is your area between curves.